Do we still need to understand data structures and algorithm in the face of AI and vibe coding? The answer is yes. Last week, the Google Cloud CTO explained that we humans in the face of AI boom need to understand the fundamentals in order for us to be able to compete. Merge sort is a very popular algorithm used by some programming languages under the hood. Languages like Python, C++, Rust, Swift, and so many others. I'm going to share with you the visual representation of the recursive part to help you understand this algorithm in details. If this is the first time you are coming to my channel, please click the subscribe button to help the channel grow, and also turn on your notification bell for any time we drop new videos. Merge sort uses divide and conquer pattern to sort arrays. It recursively divides each array into two halves, then merges the two sorted halves into one sorted array. The merge step compares elements from both halves and builds a new sorted list. The time complexity for this algorithm is big O of n log n in best time, worst case, and average cases. For the space complexity, it is big O of n. Reason is because we create a new list when we are sorting the array. So for us to implement this algorithm in JavaScript, I'm going to open a new folder. Let me create a folder called merge sort. I'll open this in VS Code and quickly create a file called merge sort here. I will create a function called merge sort. This function is going to take a list. So remember that this function is going to be a recursive function. And as a result, we are going to add a base case. So the base case for this algorithm, it's when the list has a single item, right? We return from the list. So for this, we'll do list.length. If it's less or equal to 1, we return the list. We need to get the middle of the list. For that, we'll create a midpoint. So the midpoint is going to be a value that we'll get from math.floor, the list.length divided by 2. So this will give us the midpoints of the array. We'll take the first array. So the first array, I will call it slice, or let's name it left slice. So left slice is going to be list.slice. Then we pass in 0 and midpoint. So the middle will give us from the left hand side to the middle. We will also do for the right slice as well. So the left slice will give us from middle to the end of the array. Once we have gotten from middle to the end of our array, the next thing is for us to recursively divide anything on the left and also recursively divide anything on the right. I mean the arrays, divide it until they have only a single value. So for that, we'll say const left array is going to be, we call merge sort again on this array and pass in the left slice. We define another variable to store the result of the slice from the right hand side. So once we have recursively divided this and get the left array and the right array, the next step is for us to merge these arrays and return it. So we are going to call a function called merge and passing the left array and also passing the right array. So with this, we have been able to create our merge sort function. The only thing remaining is for us to create the merge function, which the purpose of the merge function is just basically to compare the left array and the values in the right array. So let's go ahead and create this function. We create a function called merge. We'll pass in left list and we pass in the right list as an argument to this function. So let's create a list to store our results. This list is going to be an empty list. We need to create a variable called I, which will be 0, and a variable called j, which will be 0 as well. So what we are going to do, we create a while loop. So the loop will continue to run until either the left array is exhausted or the right array is exhausted. So let's create a while loop. So we say left list dot length if it's greater than I. So while left list dot length is greater than I and right list dot length is greater than j, this loop will continue to run if this condition is met. So we'll now do a comparison. So we'll open an if statement. In this if statement, we'll say if left list of I, that is the item right on the left hand side, if it's less than item on the right hand side, which is right list of j, right, we add the value to the result list by calling result.push. So we push in the left list of I. When we do this, right, remember that this comparison is already made, so we need to move to the next value in the array. So for us to move to the next value in the array, we do I++. So let's do for else. If that is not the result, that means the result on the right hand side is less. So we need to add it back to the array. So when we've added this, we do I++. So this will take care of the comparison between the left array and the right array. But in some cases, right, if this loop exists, right, we still have some item left in the left list or right list. So as at that, we need to also create a while loop to exhaust those items. So we'll do left list dot length if it's still greater than I, not 0, sorry. Then we push the results. Do result.push left list of I. Then we increment I until we run out of option for the I. We also do the same for the j. So we do result.push for j. We push in right list of j. Then we increment j. So when we are done ensuring that all the lists have been exhausted, we return. from this function. So with this, we have the recursive part that ensures that the array is divided until we have a single item in the array, and we also have a function, a helper function, that helps us to sort the items. So this gives us a complete working solution. So let's go ahead and test this function. So I'm going to call the merge function. I'm passing some unsorted arrays. So for this function, let me pass in some arrays. So I will pass in 10, 13, 2, 5, 2, 9, 8, 7, 0. So I will open up my console and call this function to see what we have. So I will do node merge, and boom, we have a sorted list. For us to understand the recursive part of this algorithm, we have to recall that the core stack has this behavior of letting the things you put in first come out last, and the things you put in later come out first. This will help us to understand how recursion works. For the first part of this merge sort, we passed in an input that has this value, right? So remember that it uses a divide and conquer pattern to solve its problem. So at each point in time, we will always divide any input that is being passed into this function into two. So those inputs, we call them left and right, which represents the right values and the left value. So at the beginning, we passed in this function, the middle is 4. The left values are 10, 13, 2, 5, and the right values are 2, 9, 8, 7, 0. Once we've gotten this value right, we will call the merge sort again. Remember that the aim is to divide until we have one item left. So when we call the merge sort on the left value, we will have this as the input, 2 will be the middle point. Then when we divide, we have 13 and 10, 2 and 5 as the left and the right value. After we've gotten this, we get to this point again. This will call merge sort again, which opens a new core stack, right, with all the values that we are going to pass in. So when this opens up, we have an input of 13 and the 10. The mid value is what? 1. And the left is 10 and the right is 10. So at this point, when we call merge sort on the left, 10 is going to return because we only have one item in it. So when we call that, we have 10 returned from this function. So when 10 returns from this function and it gets pops out from the core stack, we have 10 as the return value of the left array. So for the right array, remember that we've divided and it's 13. So 13 will be called again. When 13 is called, it gets to here, and we are checking, is the length less or equal to 1? It's equal to 1. Then we return. So when we return from this function, we have the return value from this function as the left being 10, the right being what? 13. Then we call the merge. Remember that the essence of merge is to help us compare the values that are less, sort them either in ascending or descending order. So, but we are sorting ascending order in this case. So what we are going to have from this is 10 and 13. And when we have 10 and 13, we return from this function. So when we return from this function, remember that we started dividing from the left. So the return value for the left will be 10 and 13. right will be get called. So we pass in 2 and 5 to the right and call the merge sort again to keep on dividing until we have a single item. So when we call the right, we have 2 and 5, left is 2 and right is 5. Then left will be called. So when left is called, we have to return from this function. So when we return from this function, we have 2 as the left array value. Also, we call the right with the value of 5 as the single item in the array. When this item is called, it's going to be returned from this function. So when it returns, we have a single item here 2 and a single item here 5, both in left array and in right array. We pass it to the merge function, which compares and return this as sorted. So when we return from this function, it gets us to where we started initially from our dividing. So we now have the left array as 10 and 13 and the right array as 2 and 5. So we pass both arrays inside our merge function, and merge will compare them and sort them, and we return this, right? 2, 5, 10, 13. So in this case, left from where we started has fully been sorted. So we have those fully sorted return from here, which is 2, 5, 10, 13. So we still have 2, 9, 8, 7, 10 non-sorted, right, for the right. So we continue the division again. So this gets to the right, we call the merge sort on the right. So when we call the merge sort on the right, we pass in the values that are for it. Then the mid value is what? 2. So we have for the left 2 and 9, 8, 7, 0 for the right. We divide again for the left. We continue to divide from the left until we get a single value. So let's go ahead and divide. So when we divide, we have 2 and what? 9. We are getting closer from returning all from the left, right? So we divide again. We have to return from this function. So the value for the left array now is 2. Remember that the right is what? 9. We call again. So when we call again, we return because we now have a single value. So when we return from this value, right, we have left array as 2 and right array as what? 9, all sorted. We pass them to this merge function, right, to sort them. It returns what? 2 and 9. So when it returns 2 and 9, the left has been fully what? Sorted. It now remains what? The right. So we have 8, 7, 9. We continue to call the right. So when we call the right, we pass in this value. The mid is 1. The left array will be 1 and the right array will be 7 and 0. So we call the left again. We have 8 as the value, a single item in this array. We return. This is already returned. Then we also call the right because we still have more than one item there. When we call the right, we pass in 7 and 0. So the left array for this will be 7. The right array for this will be 0. Then we pass 7 to the left and call. And when we call, this will pause execution and open a new call stack. So when it opens a new call stack, 7 is a single item in this array, so we need to return. So when we return from this function, we have 7 inside this array as sorted. Then we call for a right, which is 0. So when we call for right, we return from this function. We have 7 and 0 as left array and right array. Then we pass both arrays, right, into this merge function. Merge with merge and return what? 0 and 7. Remember that this is the right value, right? So when we return, we have 8 all sorted, 7 all sorted, right? We also pass them into this function. This because this is where he paused the execution initially, right? We pass them to this merge function again. The merge function will compare, sort them in ascending order, then and give us back 0, 7, 8 as sorted. So 0, 7, 8 are sorted will be the right. At this point, this one is sorted and this one is sorted. We pass it to the merge function again, right? So this will return 0, 2, 7, 8, 9 all sorted. So when we come back here, we now have the left array sorted, the right array sorted, right? So we pass this to the merge function again. So merge will merge both of them and return the fully sorted array. So the trick here is to continue to divide until you get a single item, right? Once you get all single item, you now start comparing them and building them up again until you get a fully sorted array. So if you still feel a bit confused after going through both the coding part and also the visual representation, what I will urge you to do, right, is to get a piece of paper, write down the code, each step of the recursive part. That will help you to get a hang of this algorithm. Thank you for watching. See you next time.